Good afternoon, everyone, and welcome to the session on equity and explainability of artificial intelligence algorithm. Dealing with personal data leads to several challenges, and among these, we have the need to generate algorithms that are fair so that they do not discriminate people, and we also should try to build algorithms that are not treated as a black box, so we should be able to explain why an algorithm generated a certain outcome. These are not just societal challenges, but decision makers are actually requiring businesses also to deal with these aspects. So in this session, we're going to have 3 experiences on these 2 aspects, and our speakers will provide us with concrete examples on how to build fair and explainable algorithms. So, without further ado, I would like to introduce the first speaker, who is Carlos Castillo from Universitat Pompeu Fabra here in Barcelona. Let's welcome him.
Thanks for coming here. It's really exciting to see Castellano, English? English? Okay. So it's really exciting to see a room full of people interested in this topic. So let's start, I guess. Okay, great. So again, my name is Carlos Castillo. This is joint work with Sara Hayan and Francesco Bonchi. And I will try to stay within the 10-15 minute limit that I have been given. So there is a dangerous reasoning that I think it has to do with how we technologists present technology and the trust that we have in the tools that we develop. And that reasoning is the following, that decisions done by humans consider a mixture of so-called objective and subjective elements, but decisions made by a computer or by a system will only take into account objective elements, and then if people can discriminate because they have this subjectivity, then machines cannot discriminate because they don't have it, right? And I think this is a dangerous reasoning. I will try to explain why, right? So by giving some examples, ideally. So is this working, the clicker, or not? I think it is. Yeah. Okay. So. First of all, I think all of us understand discrimination in a way that is a bit narrow, right? So I tend to consider discrimination. So when somebody tells me I was discriminated, I understand that this means that this person was treated differently, right? This person was treated differently because this person belongs to a certain group, because she's a woman, because he's gay, or whatever. The person was treated differently. However, discrimination has a broader definition, which has to do with impact. Not only treatment, but impact, right? So in this case, if I tell you that in my company we have 200 employees, out of which 1 is a woman, but I tell you that I have never treated women differently in my hiring processes, you can tell me, maybe I believe you, but there is an impact that your hiring policies are having, and I can see that impact in the fact that you are not hiring women, right? So there is this first difference between treatment and impact, and I think what should concern us as developers of technology and researchers is to focus also on the impact of the technology, right? So there are many typical scenarios that are addressed by, let's say, ethics and law around discrimination, and it's typically these scenarios that have to do with the public sector. They speak about access to public benefits, access to alternatives to prison, and many other similar fields. In the case of banking, I think access to credit is perhaps one of the fields where algorithmic discrimination has been studied the most. However, in any system that you can have different impact for different population groups, I think there is a concern, or there may be a concern about potential for discrimination. And this discrimination actually has 2 ways in which it can be manifested. One is group discrimination, and the other is individual discrimination. So group discrimination has to do with different groups having different, for instance, rates of hiring or approval or whatever. And individual discrimination has more to do with people being treated in an inconsistent manner. And both are a matter of concern. It's not only, the problem is not only treating groups in a similar way on expectation, and it's not only treating people consistently, because you can also treat people consistently bad. Right? So my next slide. So let me give you one example. So this was done with an automated browser. This is with a system called AdFisher. And basically what they do is that they build fake user profiles for Google. They have a list of web pages that they should visit, that these automated browsers should visit, and they navigate through the same website, so they are equivalent, right? They are equivalent behavioral profiles. The only difference between these two profiles is that in one of them, the person registers in Google and indicates he's a man. In the other, the person indicates she's a woman. And in this scenario, if both the man and the woman search for job, and this was the result of this study from 2015, is that women will see less of the jobs will see less ads for high-paying jobs. Right? So on average, they will see jobs that pay less. Right? And there has been no difference in their behavior. The only difference is that one of them said, I'm a man, and the other says, I'm a woman. So this is not treatment, it's a difference in impact. And this difference in impact can be actually measured. And the way in which this is usually measured is through risk ratios. So basically, every time you go to one of these systems in which you can have a negative outcome, so suppose I apply for a credit, and then the negative outcome will be I don't get the credit, right? I don't get the loan. Or maybe I apply for a scholarship and I don't get the scholarship, right? So I have a certain risk. In some cases, the average risk is very high, right? So if I apply for a scholarship and they have a 5% acceptance rate, so that's my risk is 95%. However, the risk for different subpopulations may be different. So maybe if I have a disability, my risk is not 95%, but 99%. Maybe if I'm a woman, the risk is 96%, and if I'm a man, the risk is 92%. So there may be differences in risk, and this is one of the most obvious ways in which you can certify whether the impact of a system is different on different groups, is by just looking at the difference in risk. Now, there is another example, and I'm going to speak more about this, about rankings, right? So suppose you're searching for candidates for a job. And as I'm searching for candidates for this job, for instance, I was searching for an economist. And I search in a job search engine like LinkedIn or Xing, and I noticed that out of the 10 first results, there is only one woman who is an economist. However, if I look at the top 40 results, it's actually 27% women. But in the top 10 results, it's only 10% women. So there is a distortion in the ranking. So if I look only at the top of the ranking, I will see much less women than if I look at 40% of the ranking. Now, however, notice that woman is in position number 1. So you could argue maybe it's only one woman, but it's in position number 1, which is the best position to be. So is this fair representation of the percentage of economists who are women or not? This is an important question. So in general, the problem is that when we build search engines and recommender systems, we usually take into account the relevance of these results for the person who is searching, right? So this is what we do is we apply this principle that you should show first the results that are more likely to be relevant for the user, for the person who is searching. However, we are not ranking documents anymore, and we are not ranking products anymore. Sometimes we are ranking people. Sometimes we are ranking business. Sometimes we are ranking politicians. We are ranking news. We are ranking groups. We are ranking objects that have interests. And those interests can manifest in the way in which we treat those objects can lead to success or failure. In some cases, let's say career success, social success, political success, and even, if you press me, reproductive success, right? So an affective success. And many other things that are deeply personal, and they have to do with the way in which we rank people, for instance, in a recommender system or a search engine. Now, in general, in these cases, what we look for is the exposure. So we try to equalize exposure. So this is, you probably have seen, if you look at any search engine, or even if you have done eye tracking studies in your own applications or apps or websites, you have seen that people tend to focus on the first results much more than on the next ones. And so what we care about in one way is to provide different people the same exposure. And this can be affected by the way in which we rank people. So suppose you have different candidates who have applied for a job, and there is a standardized test that you have applied, and it so happens that the men have obtained 82, 81, and 80 points, and the women have obtained 79, 78, and 77 points in this test. And suppose that this is given as the relevance of these groups, and you need to sort them out. So we go and sort them by this score, and what we obtain is that the difference in relevance between these results is very small. So the top relevant is 81 points, the bottom relevant is 77. So there's a very little difference in relevance. However, given that the top result is examined much more than the second result and so on, the difference in exposure is vastly different, right? So in this case, on average, men have a little more, for instance, relevance than women in this example, right? It's a bit of sexist example, but you get the point. However, the relevance is very similar, but the exposure is vastly different. So the system has taken, in this case, a pre-existing difference, a pre-existing gap between whatever two groups. They can be national foreigner, men, women, whatever. And it has exaggerated this difference through ranking, right? And this is a problem because we would like, ideally, to provide to these two groups relevance proportional to their exposure. And this is the same in also in cases of two-sided markets, you have the same problem. You have your objects that you're ranking, maybe Uber drivers or people who, whatever, like people who work in this platform economy, and you want to give them exposure proportional to their relevance, right? In general, you have these sort of measures, right? Like disparity, like the way in which you're treating them different, right? So you basically have to look at to what extent you're giving exposure that is proportional to utility in one group or the other, right? So are you giving enough exposure per utility unit to both men or women or not? And then you can also include here in this calculation the click-through rate. So if you have click-through rates for your application, for your system, you can also incorporate them into the calculation of whether you're giving people the relevance they deserve. And deserve here is a very fuzzy concept, but it has to do with the utility that your system computes for those people. You can also do, there are also systems for constrained rankings, right? So you can say, well, let me have some business rules that tell me that, for instance, among the first 10 results, I shouldn't distort the probability of finding a member of a protected group by more than a certain amount, right? So for instance, you can say in the case of economists, there are 40% economists who are women, then I will impose that in my top 10 result there should be at least 2 women, because that's 20%. I'm being flexible with the amount, with the representation of this group. And there are methods by which you can constrain these rankings and say, well, I have a minimum and, for instance, a maximum number of people that can be from the same group in one case, and then that forces me to move a bit to reorder the ranking and have still a good ranking, but one ranking that respects certain rules, right? And these rules have to do with can have to do with diversification of the results, or sometimes just the representation of a protected group, right? Now, here there are 2 different goals, and you will find, most likely if you start dealing with these issues in your own organization, you will find this, you will arrive at some point to this confrontation, right? And let me try to clear this confrontation. So there are 2 cases in which you want to incorporate fairness considerations into an algorithm. The first case is the most obvious one, and this case will be an easy sell within your organization. Is in the case where your system is producing a prediction that for a group is discriminating them even if that group has a higher utility, right? So for instance, I have analyzed some data from university admission in Chile, and we have found that, for instance, the kids who come from public high schools that are less funded, they tend to have lower scores in the selectividad, in the admission test for the university. They have lower scores, but if they make it into the university, then they have higher grades. So this means that the selectividad, like this university test, is discriminating against them, and it's also harming the university, because the university doesn't get the best candidates. It gets the candidates that get the highest score in the standardized test. And in the case of candidates from public school, this actually creates a distortion, and the distortion is bad for the candidates and for the universities. So in that case, you really want to remove discrimination, right? Discrimination is really using information that is irrelevant for making a decision, or giving a disadvantaged treatment to someone in this case. Now, the second case is a much harder sale. And the second case is really where you have a tool or a system, and you have either a voluntary commitment or a legal commitment or some values, and you want to enforce those values. And you have, in this particular case, you want to provide equal opportunity, right? So suppose in another universe, like these kids from public high school indeed had lower grades in the university. So then we could say, well, they didn't choose to be born in a family that couldn't afford a better education. They were randomly assigned to such family by fate. So what we want to do is to equalize the opportunity for them at this point, which is access to the university. So we want to provide them equal opportunity. And we are going to do whatever positive action policy we can to increase the representation among the students who are admitted. So these two cases are vastly different, and you will have very little resistance trying to introduce something that reduces discrimination, and you may face a lot of resistance introducing systems that provide equal opportunity, because most people think that what they have, they deserve. Interestingly, most people think what they have, they deserve. They earn it. It's not true. So recommendations are, first, to document model creation. This is rarely done in organizations, and I think it's really important. So just as data sets, just as we start to document data sets, like snapshots of our data, we try to keep some metadata for them, we should do something similar for models, like who created this model, on which data it was trained, on which data, and so on. So models should be treated like as first-class citizens, right, and inside our organizations, and we have to accumulate enough metadata about our models, because otherwise we will not know how to evaluate them. Second, we need to evaluate the performance of these models from the perspective of disadvantaged groups. And this is rarely done for considerations of fairness that are, I think, misplaced. So sometimes you just don't want to record a certain column in the data. I don't, given that being a man or a woman, I think is irrelevant for this purpose, I will not record this column. That, I understand the reason for doing so, but first, it's ineffective, because all these protected attributes are encoded in non-protected attributes, right? And your model will be able to classify men and women by the other attributes anyway, right? So even if you remove this column, you may still have a system that discriminates against one group. And second, you are not able to audit your system, right? If you don't know who is a man, who is a woman, who is Spanish, who is foreigner, who is rich, who is poor, then you will not be able to evaluate if your system is harming one group more than the other. You can remove the column in the modeling phase, but in the evaluation phase, you have to bring it back and say and determine if the performance of your system is the same for both groups. And third, we all need to engage with the people who benefit or suffer from the consequences of our systems, right? And this has to do mostly with understanding what are the consequences of this algorithmic system when they are deployed in practice, right? There is this process that you can take a look at. It's called algorithmic impact assessment. So this is very similar to an environmental impact assessment, right? So if you're going to build a mine next to a river, then you need to present an environmental impact assessment that explains very clearly what are the impacts of your business on different communities and different and how you're going to measure this impact and so on, what are you doing to mitigate it and so on. The same happens with algorithms. Particularly in the public sector, there is this proposal that any algorithm deployed in the public sector that deals with people, and if the data comes from people, then this is an algorithm that deals with people, should have an algorithmic impact assessment before being deployed. There are more things to read here, and there is something very interesting happening in Barcelona in January 2020. We're going to have here the Fairness, Accountability, and Transparency Conference. It's an ACM conference that deals with these issues, and the first edition was in New York, the second edition in Atlanta, the third edition will be in Barcelona, and here you have more materials to read if you're interested in this. Sorry if I went over time. Thanks.
Okay. Is there any question for Carlos? We have time for one or two quick questions. Okay.
Yes.
I think you raised some very interesting points, but like the one you mentioned about not recording the data, how do you reconcile this? Because I totally support you in the sense that we should discriminate positively, let's say, or correct it. But how do you reconcile this with current GDPR and the such? Because people are very afraid of
yes,
I mean,
of course.
I understand the
yes, so of course. So the minimization principle states that you have to only use the data that you require specifically for your application. But then this is about expanding the scope of your application to include an evaluation that is non-discriminatory. So for instance, you can say, my application is a recommender system that should be non-discriminatory. This is my application. And to be non-discriminatory, I need this element of data. So I think it's just justifiable. The GDPR asks you to justify why do you need it. And in this case, I can say, well, I'm going to conduct an algorithmic impact assessment of my system, so I need this protected attribute for this purpose, which is to evaluate if I'm having a differential impact on this group.
How about balancing those data into, if, for example, there is two groups, one with less representation. How about balancing all this data and train two different models into different subsets, and this way all two models will have the same weight, and at the moment to put it in production, merge both models.
Yes. So it's okay. So this is a good point, right? So sometimes people say, well, should I use one model that uses a protected attribute, or and have, like, in addition to the optimization for reducing the error, has another term that, for instance, penalizes when the two groups are affected differently, right? So this can be done. In other cases, what people do is that they create two separate models, one for one group and one for the other. So I think it depends on the application. That's more like a mitigation measure, right? And there are packages like IBM 360 that they have like several implementations of models that are non-discriminatory. But the first stage is just the detection, and for the detection, perhaps it's clear. But there is no single answer. Sometimes it's best to have two models. Sometimes it's best to have a model that incorporates this attribute. In any case, both cases are often better than just having a single model when the minority is much different than the majority, because then the model will not work for the minority.
And in the case that you want to solve this issue, introducing a variable, a fixed variable for patting this bias and correcting it, do you think it's good to inform to the public that you are introducing this bias?
I think I think one.
And to trade only one model.
Yeah, so I think it has to do with. I think the information has to do more with the purpose, right? So again, coming back to the question about the GDPR. So there is a purpose here. The purpose is, for instance, in this system is built in such a way that the performance for these different groups is never off by more than 20% with respect to each other, right? And then you inform the public that your purpose is to provide a performance that is equal across the board, and this is the purpose by which you are collecting this data or by which you are developing the algorithm. The specific measure of mitigation, it may change because things are changing, right? So specifically how you achieve that, it may be too dynamic to inform the public. But the goal, I think it's can be more stable, perhaps. Okay.
Okay, let's thank our speaker again.
Thank you.